Possible causes of panel heating can stem from several issues. Firstly, loose connections are a common culprit. Ensure that all connections, including those between the breakers and the bus bar, are adequately tightened. Loose connections can create high resistance, and that resistance generates heat. Secondly, the bus bar itself may be undersized. A 100 amps panel might not have a bus bar that is adequately sized for the current being drawn. For example, 3 circuits each drawing 17 amps equals 51 amps total. Consider upgrading to a 125 amps panel with a larger bus bar to provide additional capacity. Thirdly, the circuit could be overloaded. While the calculated load of 15 amps might appear to be within the 80% rule for continuous loading, the actual measured load of 16 amps to 17 amps could still be overloading the circuit. This could be due to improper load balancing or additional unexpected loads being connected to the circuits. Fourthly, there may be heatsink issues. The panel enclosure may not be providing adequate ventilation. Insufficient ventilation causes heat to accumulate. Check for any obstructions or blockages that might be restricting airflow around the panel and the breakers. Fifthly, the breakers themselves could be faulty. The breakers might not be tripping properly at their rated current. Replace the existing breakers with new, high-quality units to eliminate this possibility. Considering the impact of a 1 amp load difference, while the 1 amp difference between the 80% load limit and the actual load may seem insignificant, it can be enough to cause problems, especially under sustained load conditions. Overloading a circuit, even slightly, can lead to increased resistance, reduced breaker tripping efficiency, and potential fire hazard. Recommended actions include firstly tightening connections. Verify and tighten all connections throughout the entire system to eliminate any potential points of high resistance. Secondly, upgrade the panel. If the bus bar capacity is insufficient for the actual load, upgrade to a 125 amps panel with a larger bus bar to provide more capacity and better heat dissipation. Thirdly, balance the loads. Ensure that the loads are evenly distributed across all of the circuits. Balancing prevents any single circuit from being overloaded and reduces the overall heat generated in the panel. Fourthly, install compact fluorescents or LED. As previously recommended, replace the incandescent lamps with comparable compact fluorescent lamps or LED lamps to significantly reduce the load on each circuit. Fifthly, inspect the heatsink, which is the panel enclosure. Check for any obstructions or blockages that might be restricting airflow around the panel and breakers. If necessary, install a ventilation fan to improve cooling and prevent heat accumulation. Sixthly, replace the breakers. If the breakers are suspected of being faulty or are old, replace them with new, high-quality units to ensure proper operation and prevent overheating. There are also additional considerations to keep in mind. Firstly, check for emergency lighting. Check if any emergency lighting is connected to the same subpanel. Emergency lighting loads should ideally be separated from normal lighting loads to prevent overloading during normal operation and to ensure the emergency lights function reliably. Secondly, consider harmonic currents. Harmonic currents from electronic devices such as dimmers and LED drivers can cause breaker overheating. Identify any sources of harmonic currents and consider installing harmonic filters to reduce their impact on the electrical system. Thirdly, monitor the load profile. Monitor the load profile over time to identify any potential spikes or sustained overloads. Monitoring can help identify any hidden loads or intermittent issues that may be contributing to the overheating problem.